Good day, ladies and gentlemen. My name is Miss Beatrice, and I'll be taking you through this subject called computer studies. And then we understand that computer studies looks more into inside the computers, what really happens inside a computer. We are not looking at the physical part of a computer, what's a computer or what's not. No, computer studies, we are trying to understand the computer inside, how it operates. All right, so now let's look at a few contents, and then most of these informations I've discussed them with you already when we're discussing about our lecture notes. So now let's see if you remember what were numbering systems, logic gates, types of malicious harmful threats to computers, and types of memory in terms of technology. So I believe most of students experience a little bit of a difficulty in understanding the numbering system. Computer studies is more into calculations, and logic gates is also calculations. We need to understand the logic gates, the logic, the truth tables or logic circuits, right? And then the malicious harmful threats to computers, what can harm the computers, for example, and then memories, like a random access memory, for example. You understand different types of memories. Well, let's start with the numbering system. How many numbering systems do you remember? Do you understand what is a binary? What makes up a computer, basically? How do you think the computer understands? Okay, let me put it in a different note where we can able to understand. So basically, as humans, we stand here. As human, we understand the language, like for example, what you call English, okay? And then this is what we call higher language when it comes to computers. Okay, then we have what we call a machine language. So we have a language here, can't recall the name. So the machine language is made up of zeros and ones, all right? And then we have our translator here that translates our language. So now with the machine language, for example, when you are typing in some information in a computer, we type it in with the English word. Like I'll say, my name is Esther Beatrice. Okay, and then it is translated by the compiler here. There is a compiler here, right? It translates our so that we are trying to communicate with the computer. Then the computer, these words, when they come here, they are translated in zeros and one. And each letter, like for example, this E is made up of what you call 8 bits. When you're talking of bits, these zeros and ones are what we call bits. Okay, now each letter is made up of 8 bits. Imagine now if it's Esther. So how many? So that will be 8 times 5 bits. That will make up, that's how the computer will understand that machine language, right? So now, when we are talking of a machine language, now that's when we are talking of binaries. Binaries is made up of a 0 and 1, right? And then the base is 2 because it's of 2 letters. Okay, so numbering system is made up of binaries, which is of a base of 2. It is of a decimal. Decimals, these are the normal numbers that we use every day, 0 to 9, and then that makes up 10 numbers, and then it's of a base of 10. And then we have octal, which is made up of 8 numbers, and then the base is 8. And then we have what we call hexadecimal, which is of 16. That's a base of 16, which starts from 0 to 9, and then A, B, C up to F, right? So now, with these numbering systems, we need to know how to convert these numbers. Like, for example, we can convert from binary to decimal, from decimal to binary, from binary to octal, octal to binary, binary, like all these types of, we need to understand how to convert from each one of them. Okay, so you need to understand how to convert each one of them. So, but for me, in this time we have here, I'm just gonna show you how to convert from binary to decimal, and how to convert from decimal to binary. But remember, in the notes that we have discussed, I've showed all the examples on how to convert from each one of them, either from octal to decimal, or from a hexadecimal to octal, from decimal to octal, and then like that. We need to know how to convert each of. So basically, computer studies, you need to understand mathematics a little bit. Right? Example of a conversion. Now let's look at the converting binary to decimal. So we have an example on the screen there, which is trying to convert that numbers to decimal. How do we do that? Okay, so I don't have a calculator here with me, unfortunately, but let's say we have now 101. Okay, so we look at this number here. Okay, so it's of a base of 2. So now we are trying to convert it to decimal, and let's see what this one makes up, what number is made up of this binary. So what we do is, since it is of a base of 2, so we use that base of 2 and then we calculate it. Okay, I'll put it like that, a little bit wider, and then I will say start with a 2 out of, okay, this base of 2 is what we are using here, and then we use it of a power of 0, and then we'll say of power 1, or power 2, and power 3. Okay, and then if it's after the comma on this side is always a negative side. All right, that's why if you see on the side there, it's saying -1, 2 to the power of -1, and then the next one is 2 to the power of -2. So, but I'm not going to give you that example. That's the example for you to look. We are going to look at this one. All right, so now 2 to the power of negative, or of 0, basically that is what? That is a 1. Let's see. Okay, I don't know. Okay, we try to times. Okay, and then we try to add it together. We are just converting this one to here, to this one, and then this is 0 times 2 to the power of 1 plus 1 times 2 to the power of 0. Okay, then from there we convert this one. This one will give us a 8, and then this one will give us a 4, and then this one will give us a 0, and then this one will give us a 1. So now we will add these numbers together. Once we add them together, then they were going to give us what? This is going to give us 13. 8 plus 4 is 12, and 12 plus 1, 12 plus 0 is 12, and then 12 plus 1 is equal to 13. So in a decimal value, then from this number it makes up 13. That's a simple conversion. Okay, I hope it's clear on that. And then once we must always not forget the base. We must always put, for example, there we calculate it, we got the answer, and then the answer should always be to the base of 10, because we are converting to what? To decimal value. So now let's look at an example of converting decimal to binary. Okay, how do you do that? We divide by 2, because we are converting to binaries, and binary is of a base of 2. So now example of binary decimal to binary. How do we convert that? Okay, don't mind about my handwriting. Just follow what I'm saying. So now 162, we want to see what are the binaries out of that. So we divide. Okay, we take our 2, for example, right? Okay, then we divide, and then we look at the reminders. We put the reminders here. If we divide 162 divided by 2, we are going to get 81. What is the remainder? There is no remainder. The remainder is 0. Then we divide 81 by 2. There we are going to get a 40. We have a remainder of 1. Then 40 divided by 2, we are going to get 20. There is a remainder of a 0, and then 20 divided by 2, we are going to get a 10. The remainder is 0, and then 2 divided by 10 divided by 2, it is a 5. Then we are going to get a remainder of 1. There is a 2 again, because here there is no remainder. 40, there is no remainder, no remainder, no remainder. Then 5 divided by 2, there is a remainder, right? Right? Then we are going to get the 2, and then 2 divided by, okay, we can continue. 2 divided by 2, then there's no remainder, right? Then we are always converting 1 divided by 2, then there is a remainder. So now we put these are the binaries that we are going to get, okay? But how do we count them? We count them upwards. So we are going to start off with this one, the last one. So basically our answer will be 162 of a base of 10 is equal to 101,000. We are looking at all these 0, 1 and 0. Okay, then we are going to convert it. We know we have converted to the remainder of 2. Have you got that? We just divide and then we look at the remainders. Now this is, so basically in binaries, once you type in your computer 162, the CPU will process this, and then when the machine language is going to understand, or the computer is going to be interpreted, and then it's just going to see this as a binary, and then this is in a form of a machine language, and then this is what you understood. This is what you have typed in your computer. Okay, are we clear on that? And if it's of a remainder, like let's say it's 162.375 as it's on the screen, after the remainder there, after the comma, we are always counting it down, not upwards like that. Okay, so now that is just a conversion of decimal to binary, and then binary to decimal, if you understand. So now let's look at the logic gates. How do you understand the logic gates? Logic gates, this is when we are looking at now the switch on and off. Still, we are looking at the zeros and 1, right? When it's a 0, then that is off, and then when it's a 1, that means it's a on, right? The circuit is on or off. Okay, it's just like an electrical circuit. When you switch on or off, that's how we understand. So now logic gates also now looks at this. Now we have different types of logic gates, all right? And I'm just gonna give you an example of one logic gate, but we have looked at different types of logic gates already, and then I've given you enough examples on each of a logic gate. And then now each logic gate, to understand it, we need to also understand what you call the truth table. Each of a logic gate has its own truth table, and then that's what will make you understand. And believe me or not, these logic gates will come in the exam, and you need to understand how do we calculate the logic gates. Okay, so now we have logic gates such as OR, XOR, NOR, AND, NAND, NOT, and then so forth. You need to understand those different types of logic gates. Okay, so I'm just gonna look at the example of a logic gate, which is the AND gate. What is a gate? An AND gate. Okay, as you can see on the screen, that is a symbol of it. That is a symbol of a AND gate. All right. And then how do we read that? That stands in the Boolean algebra. It is made up of A dot B. All right. Okay, and then if you can see there, that is a truth table. If you can see on the right, that's a truth table. That is made up of what? Let's understand this better. So, looking at this, we have now our A and B. So now we have to look at the zeros and ones there. Okay, so if you have to calculate something like this of our AND gate, So you can see there is an A there and then a B, and then this is now the truth table of okay, we have a 0 0 and then a 1. We have a 0 1 0 1. Okay, so now to get the answer, it will say A and B. When it comes to A and B, 0 and 0, and then it will give you an answer. If it's 0 and 1, and then to give you an answer of a 0, and then 1 and 0 to give you an answer which is 0, and 1 and 1, it will give you an answer of a 1 when it comes to end. That is the logic table of the end. Okay, you just need to not really memorize how the truth table of this. You just need to understand that the logic. That's why it's called a logic table, because you just need to logically understand how this works. These are the inputs, but now you have to look at if it's A and B. Now you look at the output, 0 and 0. It will give you an answer of a 0. A 1 and a 0, it gives you a 0. A 0 and a 1, it will give you still a 0. Only 1 and 1. Okay, 1 and 1. This one is the only one that will give you an answer of a 1. That's it. That is the output of n. So you just need to logically understand this. And then these examples are all in your lecture notes if you want to understand them. And then believe me or not, this is part of the exam. And then you really need to pay attention to it. The logic table. It does not matter how it's coming. It does not matter which example of a logic gate is coming in. You just need to understand different types of logic tables of each kind. And then understand each is truth table. We call it the truth table or the logic table of it. Alright? Now, let's move to the malicious threats and types of memories. Each computer, it's actually in fear of threats. And then these are the things that we deal with. We have what you call malwares. How do you understand by the term malwares? Do you know the harmful effects it can affect the computers? So now you need to understand different types of malicious threats such as malwares, the effects of it, and then how can you prevent your computers from malwares. Okay, so we have things like antiviruses, firewalls. Understand a little bit of in depth of antiviruses, firewalls. How does one set up a firewall in their computers to protect their computers from malicious threats? Those are the things you need to understand. Now, types of memory that can be used in our computers. Have you heard of a term, what is a cache memory? When I'm talking of a cache memory, is cache memory. Have you ever Googled and tried to Google and then something will come up, what is a computer, for example? Something that is a cache memory. It is something that is most oftenly searched, and then it stays in the history, let's say, of your computer, or let's say the local network that is within your community. The most popular thing that is mostly searched is most likely to appear oftenly or most firstly on your search. That means if something is appearing more oftenly, like let me say, what is a cat? Wherever you go, let's say you go to Hobabes or something, everything when you are typing something, what is, then a cat pops up. That means that is the most oftenly thing that is most searched. And then that's what makes up what you call a cache memory. Okay, so understand the term cache memory. What is a cache memory? What is a virtual memory? What is a random access memory? What is a ROM memory? So understand different types of memories when it comes to computers. Okay, let's preview what we have just discussed. Don't mind me, I speak kind of fast, but just keep on rewinding and try to understand about these things. We looked at different types of numbering systems. Computer studies you cannot do without not knowing how to do numbering systems. So numbering system, we have things like binaries, which is decimals, we have octals and hexadecimals. And then between these four types of numbering systems, we need to know how to convert each one of them from binaries to decimals, decimals to binaries, binaries to octal, and vice versa. Okay, so now I have given you an example of a binary to decimal. how this we calculate it with the base of a 2, and then you just understand how to calculate this. And then I've given you now the example of converting from a decimal to binaries. And then mind you, when you're always putting the answers, you should always put the base where you are converting it from. If you're converting from a decimal, that is from base 10 to base 2 to binaries, because binaries is of a base. And then for you to understand the bases is like when I give you an first example. Binaries is just made up of a 0 and 1. That makes them only 2. And then the decimal, it is from 0 to 9. That's why it makes them up 10 numbers. That's why it's called a base of 10. And then of octal, it is from 0 to 7. That makes them up 8. That's why it's octal of a base 8. And hexadecimal, it is from 0 to 14 and from A to F. That makes up 16 numbers out of them. Okay, and then that's of a base of 16. Okay, now looking at terms of logic gates, understand different types of logic gates. Each one of a gate, understand it is logic table, or what you call the truth table of it. Understand how it works, and then understand how to calculate each of these logic table. Don't memorize, just understand logically. And last but not least, malicious threat and types of memories. How do you understand the term of cache memory? Can you give an example of a cache memory, or virtual memory, or the random access memory, or RAM? And then malicious threat. How can you protect your computers from this kind of threat? Through antiviruses, through firewalls. Understand how to set up a firewall, understand how different types of antiviruses. And I believe if you take all that into mind or into consideration, then I believe you'll be ready to write this kind of exam. And then from my part, I wish you all the best.